Alright, so do you remember I said my computer's going a bit slow? It is, isn't it? Objective. Calculate the volume of a prism. Okay, that's what I want you to be able to do. And really, we've already got all the knowledge that we need. Okay? So is there anyone that already knows how to work out? Okay. It's not length times width times height. That works for one prism, type of prism, not them all.
So if it's, I think this is how it is, but if it's I think I'm using this for surface area.
Okay, Steph Alexander.
It's the area of the shape on the end times the length of the.
Okay, so anyone want to use really good mathematical vocabulary?
So it's the area of the face.
Gave it a name. Steph's right, it's the, what do you say, the shape on the end. But I had a better name for that. And it's in your formula booklet. Think, is it? Maybe not in your form. No, it's on that sheet I gave you, the printout. The notes printout that I gave you.
Cross section.
Good. It's the cross section area, okay, multiplied by the perpendicular height or length or whatever you want to say. We write that down, Steph. Okay? Do you all understand what I mean by that? Okay? I will give an example here for anyone that doesn't understand. Okay? So this is why it's not just length times width times height. Because that does give you the volume of a what prism? Rectangular prism, yeah? Because if I do a rectangular prism, okay, excuse my drawing. So this is one end, right? And what's the cross-section area? It's width, length, yeah? So imagine that's not a parallelogram, it's a rectangle, yeah? Just slanted in 3D. Can you see that? So the cross-section area in this case, so if I call it like, you know what that means, yeah? So that would be length times width because it's a rectangle. And then the height would be this distance here. Okay? So the height would be that one. So the perpendicular height, because if this is the area, then this here is perpendicular to it. Perpendicular meaning at right angles. Okay? So it's length times width times height. But that's only true for rectangular prism, also known as a cuboid. Thank you. Right? However, if we change that to a different one, good choice, yeah? So let's draw a triangular prism. Hopefully you're getting better at these now. Feel free to add this to the printout that I've already given you, if that is easier, because I've drawn these prisms for you. All right, if you want to add it to that sheet and just add in stuff about volume. So here is a triangular prism, all right? But this time the cross section is what? The triangle, okay? And this is the perpendicular height, so the height is in that direction, and this is the cross section. So this time it's not length times width times height, it's what?
Times height and base.
Base times height divided by 2 times... Well then, shall we change this? So we can't call that height this time, so let's call it L. Do you know why? Because I've already got a H as a height of the triangle, yeah? So I've got to be careful that I don't represent two different things. So the area of the triangle is half base times height, so that's the base, that's the height. So we've got the area of the triangle, so triangle area times the length. So to work out the volume of a prism, it is simply as easy as you know the area of one end and you multiply it by the other dimension. So you can see why it was so important that you know how to work out the area of so many two-dimensional shapes. Because if it was a pentagonal prism, pentagon on the end and then the height, you need to be able to work out the volume. What about, obviously, if I were to draw... It's lagging again. Excuse my slow computer. It's weird when you look at this. Okay, so let's do R there. And this is my height. What would the volume of a cylinder be then? Odin? Which is?
Pi is...
So we've got pi r squared times height. So because you've got so much experience of these two-dimensional shapes now, you just have to multiply it by whatever number. Now let me ask you, because now there's two sections in the textbook that you can get on and do. If I ask you about this shape. Is it a prism?
Yes.
It is a prism, yeah? The cross section being? The L shape. Okay. Yes. Okay, so if I wanted to do the volume of this shape, yeah, so the way to deal with this one, it would be to split it however you want to, but I would actually be looking at, depends what dimensions you're given, but if I split it into two prisms, so I've got a smaller one and a bigger one, just like if you had a two-dimensional shape and you split an L into different rectangles, we just do the same thing again, yeah? So do you see how I've got a blue cuboid and a red cuboid on the end, and that's how I would do it. Just split the shape. Ava? Well, I gave you a sheet with a lot of them on, so I did say use that. The L shape is fine if you can't draw that. Maybe we'll have a lesson on trying. Just try your best. Just try your best. There is, if you look in your textbook on page 207, you can see some other examples. Maybe you could copy one from there. Okay? So in the book, they don't do it in the slant like I did. They just did it from face on, which might be easier for you to do if you like. But basically, the volume of a prism then is just, you've got to identify what the cross section is and multiply it by the height. All right? Any questions on that? All good? Okay. Recording. Right, so just to recap with some of these then. The volume of a prism, any prism, is its cross-sectional area multiplied by the height or the length that is perpendicular to that cross-section. So in this question, it calls it the base. But you now know from our work on triangles, the base does not have to be the bottom. Okay? What you're actually looking for is the shape that is the constant cross-section. So in your textbook, please, can you look at C and tell me what the constant cross-section is? Desmond.
Oh, the constant cross-section?
Yeah.
Like the shape or the area of?
What's the shape?
Oh, it's a pentagon.
It's a pentagon. So I'm going to ask you now, just to recap, how do we work out the area of a regular pentagon then? Carry on.
It is, okay. So for this specific one, it's 5 times 12 times 8 over 2, and then times...
And why is that? What's the reasoning we have? Cameron, help him out.
Basically, you do the amount of sides to shape,
Yeah.
2D shape, times the length of the base, so the length of one side.
So we basically, let's simplify it, we turn it into triangles that are all the same because we know we've got a regular shape. We then work out the area of one of these triangles. Yeah? And times the number of triangles. So I would do, guys, I'm waiting. So we've got 12 and we know the apothem is 8, so we have a half times 12 times 8, which is the triangle, and we have 5 of those, so that would be the area of the cross-section. Can I ask you for D, what is the cross-section for D, Odin? It is a trapezium or trapezoid, whichever you want to call it. What is the formula for the area of a trapezoid?
You do A was this is the top length plus the bottom length divided by 2 times height.
Times its height and its perpendicular height. Okay? So that's what you should have done for that one. Okay? And E, what's the cross section, Jelena? No, you wouldn't know because you've already packed up and closed your book, so I'm asking you to look at a page. You know what's going to happen now, don't you? Finish this off, Adriana. What's the shape? Now, what's the shape of the cross section for E? Last thing, and then we can go. Hexagon, yes, well done. And how would I work out the area of a hexagon? Yeah.
You do 6.1
Yeah.
times 6
Yeah.
times 7.
So 6.1 times 7, yeah, they put them in different places. Half of that times it by 6. Okay? Rightio. Let's go.